Action.
Hello, welcome to Homework 24.
Okay, thank you, Nick. Here we go. Homework 24. You need a reference table and a calculator for this. Let's do the first one. All answers to the nearest tenth. I just put that on there, so express all answers to the nearest tenth. Nick rolls a ball down a hill. The ball starts from rest. It accelerates at a constant rate of that. What's the final velocity of the ball if there's 7 seconds? So this is the best thing to do. Write down the variables here. Okay, when it says start from rest, that's nice. It's always giving, that's initial velocity, the starting velocity, and that's 0 in this case, 0 meters per second. It says it accelerates at 2.6 meters per second squared, so no acceleration, 2.6 meters per second squared. And we're trying to find the final velocity of the ball after 7 seconds. So it's telling us we want the final velocity is what we're looking for, and the time is 7 seconds. So you need to go to the reference table, and it's the top 5, so it's these 5 here. Okay, and you need to figure out which one of those has all of these variables in it. And sometimes you can use 2 of them, but mostly you can just one will work. So what it's going to have to be this one, because it's final velocity, initial velocity, acceleration, and time. So I like to write it down here. VF equals VI plus AT. VF is what we're looking for. Initial velocity is 0, so that's kind of nice. It's going to just drop out. Plus acceleration, 2.6 meters per second squared. And the units are often what get people here. And then the time is 7 seconds. Okay, so we can just do this math. And first, let's do the units here. Put the seconds over 1. And what you're going to see is that this second will cancel out. There's 2 seconds here, second times second. Cancel out with the squared. Okay? And then you just do that math of 2.6 times 7 and equals 18.2. So, and then meters per second. VF equals 18.2 meters per second. And I like to always check to make sure that the units make sense. Any velocity is going to be some distance over time, so that makes sense. So that's the first one. Second one goes like this. Nick Funk rides his lime green tricycle at 1.7 meters per second. He speeds up to 7.8 meters per second over the course of 6 seconds. Find his acceleration during this time. And choosing the formula, as I've said, is often the more difficult part. So the first thing, initial velocity is 1.7 meters per second. Write that down. The final velocity, that's what that is. You have to recognize that that is what final velocity is. In this case, 7.8 meters per second. The time of all of this events is 6 seconds. Time is 6 seconds. And what we're looking for, find the acceleration. The acceleration is what we're looking for. So, looking at these, VI, VF, T, and A, what formula in our top 5 right here has those variables in it? And what you'll see is it is this one. It's this one. Does not have distance in it, so it's the third one. Same formula we used before. So VF equals VI plus A times T. And let's plug in the numbers. 7.8. Really focusing on the units here. Now there is initial velocity at 1.7 meters per second plus acceleration. We don't know. We're trying to find that. And then the time is 6 seconds. So what we can do, and you have to recognize this, is you want to get this over. You want to sort of combine things as best you can. So this is meters per second. That's meters per second. So we just subtract this. Okay, you can do that. Subtract it from this side, and then I subtract it over here. And because they're the same units, the units just carry over. It's like subtracting 4 apples from 10 apples. You get 6 apples. So adding and subtracting, that's how it goes. Okay, so that is going to be, do that on your calculator, and you're going to get 6.1 meters per second. And then that's going to equal A times 6 seconds. Okay, so what you want is get A by itself. Divide this by 6. Okay, what you do to one side, you must do to the other. 6 seconds. Okay, let's do the units first. What you're going to do is keep, change, flip. I'll do this over here. I'll do it with a pen. And it is meters per second. We're going to keep that. We're going to change the division to multiplication, and we're going to flip the seconds to 1/2. So that's going to give us meters per second squared. That will be our units. And then 6.1 divided by 6. 6.1 divided by 6 is that. Rounded to the tenths is going to be 1.0. So the answer here is going to be 1.0 meters per second squared. Okay. Third one. Nick Funk drives a motor vehicle. He drives the vehicle down the road at a constant speed of 11 meters per second. Hits the gas, accelerates at a constant rate of 3.2 meters per second squared over a distance of 152 meters. Calculate his final velocity, please. So, let's do this here. Some of the variables we have. Drives at constant speed. So that's going to be, hopefully you recognize, that's our initial velocity of 11 meters per second. Hits the gas and accelerates. It gives you acceleration of 3.2 meters per second squared, or meters per second every second. And the distance is 152 meters. Final velocity, VF, is what we need. Let's look at our formulas here. Okay, and try to realize what of our formulas are going to work, have all those variables in it here. And this is often the hard part. Which one has all of the ones that we want? And what you're going to see is that it is this fifth one. VF squared equals VI squared plus 2AD. So let's use that. VF squared equals VI squared plus 2AD. Okay, so VF squared is what we're looking for. Let's plug in the numbers here. VI is 11 meters per second plus 3.2 meters per second squared times d of 152 meters. Okay, so we can let's do this. 2 times 3.2 times 152. We will do that, and that is going to be 2 times 3.2 times 152. We will get a large number, 972.8. 972.8. And then let's look at the units here separately. And if I have my pencil somewhere, let's do it in pencil. So let's just do this. So we're going to multiply the units. So this second squared times 1 is second squared. Meter times meter is meter squared. Okay? And actually, you know what I did here? This happens sometimes. I'm going a little fast. This is squared too. So, what I'm going to get for that is 11 squared. 11 times 11 is 121. 121. And then this whole thing here is going to be squared. So now I'm doing, it's going to be meters over seconds times meters over seconds. So that's going to give us meters squared over second squared. Okay? VF squared. So, and then as we said here, this is the same thing, meters squared over seconds squared. Because these are the same, you can just add them. You got to recognize that. You can, same units, you can add them. So I'll do 121 plus 972.8 equals that. So now I have VF squared equals 1093.8 meters squared second squared. Now you want to get, this is squared, so you got to take the square root of this to get VF, and you got to take the square root of all of this. Okay? Therefore, you get VF, and the square root of meters squared over second squared will be meters over second. And then 1093.8 square root is 33.07. We'll round that to the tenths. It's going to be 33.1. 33.1 meters over second. So that one's a little more complicated. Okay, a little more to it. Using that formula with the squared gets a little weird. So that's a little more challenging. Okay, let's go on to the back here. And let's go on to the back here. 1 second. Let me do this. Okay. And it says Nick Funk is driving to dance class. He's driving 23 meters per second when he accelerates at a constant rate of 4 seconds. During the 4 seconds, he travels a distance of 135 meters. Find his rate of acceleration. So, what we're going to do, what do we know? What's 23 meters per second squared? That's his initial velocity here. 23 meters per second. He accelerates at a constant rate for 4 seconds. So time is, let me write that out, 4 seconds. During the 4 seconds, he travels a distance. So your distance is 135 meters. And find his rate of acceleration. That's what we're trying to find. So with those, you go back to the reference table. What of these top 5, there are going to have those variables in it? And the answer is going to be this one, 4th one down. Okay, because it has distance in it, this one, and it doesn't have final velocity. So it is d equals VIT plus 1/2 AT squared. So let's plug this in. 135 meters equals 23 meters per second times time, which is 4 seconds, plus 1/2 A we're trying to find, and time is 4 seconds, and that's squared. So there's a lot of math to work through here, but if you just take your time and go through it like this. All right, we have to do this 23 times 4. We can do it on the calculator. Let's do the units here. What you're going to get is these will cancel out, okay? These will cancel out. The seconds cancel. So this is going to be meters, and 23 times 4 is 92. So that's going to be 92 meters plus 1/2 A, and then 4 seconds squared is going to give us 4 times 4 is 16 seconds squared. And then to simplify this, I could do 1/2. So 1/2 times I don't know how you do that. 16 divided by 2 probably, or 16 times 0.5. Either one will get you that. So this will simplify to 8. You can do A acceleration times 8 seconds squared. Okay, and that's 135 meters. I like writing the whole thing out. So what you can do, these are both meters, you can subtract this from the side, because so you could get it over here. 135 minus 92, 135 minus 92 is 43. So now I have 43 meters equals A times 8 seconds squared. So I want to get A by itself. I divide this by 8 seconds squared. What I do to one side, I have to do to the other. 8 seconds squared. The units here will just be meters per second squared, which is nice because I know that's what acceleration is. 43 divided by 8 is 5.375. Round that to tenths, 5.4. Therefore, your answer here is going to be 5.4 meters per second squared. That's the answer. Okay? Hopefully me working through that helps. So what I'm going to do is I'm going to just flash these answers for the remaining 3 to make the video not super long. Okay? Hopefully they all fit on the page. I'll do that right there. They're fitting on the page. So check these. I did it the same fashion. This is what your answer should be for 6, and your answer should be that. Hopefully you're getting this, and check your answers properly here. Check mark equals correct. Circle equals incorrect. And you want to make sure you're understanding this. Okay. Action.
I'm Nick Funk, and I approve this homework.